Okay, perfect. So good morning, everyone. Hello, and welcome to this, well, to this working day, Monday. First tutorial today is going to be about containerization and CICD. So let's jump right in. Okay, so just let me share my screen. And while I do that, maybe we can start by getting some participation from you. So okay, so we're talking about two things: containerizations and containerization and CICD. Okay, so can any one of you define either of these terms? Like, what do you know about it? About any of them? Anything? So at least do you know what CICD means? Should be. Yeah, let me give you a minute. You can see my screen, right? Can I get a reaction to that? Can you see the slides? Yeah, thanks. Okay, so anyone want to venture just an answer to this? Like anything, just tell me what you know. Or maybe it's okay. One. Okay, Almaz.
uh, Containerization, maybe putting things into one container like packaging.
Mm-hmm.
Can you say it like that?
Okay. What about CICD? Do you know what it means? Okay, go ahead. Um, okay, maybe I missed it. All right, so there's an answer in the chat box. Yes, so ETA is getting it right. So CICD is used to automate the process of software development, testing, and deployment. Yeah, okay, that's exactly correct. So yeah, so just thank you for answering, and I please just raise your hand and say whatever you this is not a test or an exam or anything. I just want to gauge you how much you know, and also just to hear from you, just to get to know you basically. So just let's jump right in. What's your colleagues have said is basically correct. So we're going to go through containerization first, and then we're going to go through over the basically an introduction for CICD, and then we will have a little connection between the two. So containerization, or it's also you can say Dockerization, because Docker is the main platform that is used for containerization. So what does it mean? It's basically uh, for when you develop some kind of an application or software, you'll have multiple. It will be it depends on multiple libraries, or there are different binaries or dependencies that run the software. And basically, containerization means that you bundle all of these dependencies together in what is called a container, and this container will run independently. Basically, you package it together, and then it can run on in any environment or any kinds of a OS without any problem. So it's going to be running isolated in an isolated manner. So it's just a bundle that it doesn't interact with it has minimal interaction with the host, and it can run on any environment. So you can develop an application, like say you are working on Your laptop is a Windows laptop and you develop some application, then you can create a container and package it so that someone who's using Linux, I don't, or any other kind of OS can run it on their platform without any problems because it's just isolated from its surrounding. It's a kind of a virtualization. So if you know what virtual machines are, this containerization is a type of virtualization, but it's just like a kind of simpler, let's say. So containers are these lightweight executable pieces that are self-contained. Like here is the rest are self-contained. They include all the binaries and dependencies of the app to run. So you don't need anything to install on your machine. They are isolated, they can run independently, basically. And because of all these three properties, they are very portable. You can basically run them anywhere, and they will be running consistently. So you are solving a problem of if you create a code in one machine and it works, and if you send the code alone, not everything with it, you send the code alone to another machine and run it, then depending on what this other machine has installed, it might not run there. So this solves the problem of that code that works in one machine and doesn't work on the other. Just to look like this on this graph, like this like layers of containerization. At the bottom, you have the hardware infrastructure. On top of that, you have the host operating system, the kernel, and the rest of the operating system. And then on top of that, the container engine will run. So this is like what Docker does. So when you install a Docker, so of course, to run a container, you have to have a container engine installed on your machine. That's where it will allow you to run a container. So on the topmost will be the container running, also a containerized app. Okay, so of course, a virtual machine is going to be all these three. It has like an operating system, while the container just is the top one, basically. Well, if you include the container engine as well, because you need that part, you have this top two. So just because it's the top one, the container is very lightweight, it's very portable, and basically it's that's what makes it like I will move next to the to the benefits of using containers. But you can understand from what I described how useful they are. Okay. Any questions so far? Does this make sense to you? What I said? So if you have any question at any point, you can just raise your hand. If anything is not clear, you can just say so. So these are the benefits basically to doing this containerized an application. So yeah, basically yes, makes your app portable. It can basically make it portable to any machine, so it can run easily. So think about, for example, I don't know, in the last weeks 0 and week 1, you are in different points. You are installing different I don't know, applications. I don't know if you have been through this or not, but you might need some particular application to run on your. So, for example, Postgres. You had to use Postgres to create SQL database, right, at some point. And you need to install Postgres on your machine to use it. So you can run through a search for, you are using Windows or using Linux, you'll search for that version that will run on your machine and install that one. But if you had Docker instead, so Docker is the engine that runs containers, you can basically download and run very fast a Postgres container. So it will be running Postgres app inside a container. That inside the container, it has all the requirements for Postgres, but it doesn't need to have this requirement on your machine. So you don't need the particular version for your OS. So you'll be running it very quickly on your machine. And basically, you also don't need to worry about like memory and stuff to installing all of these libraries, and it's taking memory on your machine. If you need the app for only a short period of time, this will make sense that you just run a container and then remove it once you're done with it. So this is portability. Scalability is like when you're developing things, you can develop your app in pieces, basically. So each piece, like for example, if your app has some kind of let's say you have a front end, you have a database at the back end, you have other parts, other different services, different parts of your application. You don't need all of them to be running in the same place. So you can create a container for each part. So it will be like similar to what's called a microservice, basically. So you'll have a database running in a container on its own. And because you can connect them in a network, basically. So I'm just saying a lot of stuff, blah, 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 that will make sense to you once you get to use Docker more and more, basically. So I was just saying that an app can be broke down into pieces, and each one you can create a Docker image, and then which will then be running on a container on its own. And basically, because each one is a container on its own, you can if a problem happens, you know where it is happening. Is easily maintainable, and it can be scaled very easily. So say that you were running just one database container, and for some reason you need another one, you can just copy paste, just run another container from the same image to create a second database. I'm just saying an example that maybe doesn't make sense, but anyway, basically you can double and scale basically the number of containers very easily for your purposes. So yeah, again, so what I was saying, the blah blah, this productivity and flexibility. When you break down application in smaller pieces, it makes it like more flexible. Yeah, so you can scale even different parts of it separately, but you can of course scale everything together also easily. Okay, so okay, here there will be the little connection between, or not little, but it's an important connection between containerization and CICD. Basically, so in the use cases, there is a microservice, the same thing I was talking about just a little bit before. So microservices is like the architecture depends on, revolve around having a small, independent, loosely coupled services working together. So each service will be in a different container, but they are all connected in a kind of network. And because they are like separated, basically you can manage them separately, which makes manage them easier, basically. In CICD, basically, so because it don't go what's CICD, maybe this will not make sense yet, but we'll come back to it later. But okay, just to mention the tools. So Docker is the most used containerization platform. So you have to get to install Docker on your machine. You have to do that step, and then you can use it. Basically, we'll go through a quick example in a bit, or a bit more about Docker in a bit. So this is like the main containerization platform. There is also here what's another important tool or platform is Kubernetes, which is a container orchestration platform. So this it's something like another it's a bigger level than Docker. So Kubernetes will work with Docker engine, but it's when you have many containers and you want to manage the deployment, networking, and like scalability and availability of containers, basically. So yeah, so this is all of it. All of I have here in the let's theory. So any questions so far? The next part will be like, I'm just going to go into Docker, the tool a little bit more, just to show you like how to use it and like the basic components of it and what you might be needing to do this week. Okay. Any questions? Sorry. Any questions so far? I don't know, maybe I was talking too quickly. Okay, just let me stop sharing. I need to share my whole screen. Okay. Um, okay, so one second. So do you, okay. Can you see my screen? Any reaction? Is it? Okay, good. So this is, okay, what you're saying is, okay, so it's just like, I'm going to go over some kind of terminology for Docker. So in Docker, there is what's called a Docker file, a Docker image, and a Docker container. So these are three things. So what we were talking about container before is the executable, the thing that is actually running. This is the Docker container. It's just like the same. But a Docker file, a Docker image, Docker file is how you create it. So it's a blueprint, basically. So I'm going to show you an example right away. So let's say here in this directory, I have a Python code. Okay, so this Python code is just like it uses a beautiful soup to just get select go to the IMB DPI MDPs the movie website and get like in the top 25 and get some random select the random movie. Basically, this is all code, just a simple code. So just one file, nothing great. So it's not, it just this is a sample, not like it's just a simple code. Why does it matter to create a container for this? But anyway, it will we're going to use this to show it. So the dependencies here are just basically beautiful soup, right? Having also Python and run it. So suppose like whatever like environment I'm running this code in and it works. That's what I want to emulate in my container. So okay, in that case, so what I said is that there's a Docker file, which is a blueprint. The Docker image is a template to running the container, and then we have the container itself where the application runs in it. So let's see the Docker file. This is what you have to write for when you're creating you're containerizing your own app. You have to write this Docker file yourself. Okay, so you can see there are like so a Docker file is called. You have to call it Docker file, just like this. No extension file for its name. And it has to be Dockerfied exactly like how it's written here. And then you have this kind of um, commands basically, or keywords. So you can see there's from. And what I'm using here is basically, this is the layer that this, how to say. So I don't need to start from, how to say. What I'm writing here is what I need is I need a container that will run Python 3.10 because this is the one I was using when I run my code. I cannot open this. Okay. So I run my code, let's say with Python 3.10, and it was working. So that's why I'm writing this in here in the base image as it's called. And you can here, you would be using like different things. You can have like a light version of Linux, or like some kind of whatever you need to run your code, your application. And then add main.py, this is calling, it's telling it to add this, which it exists in the same repository. So it will add it, add this file to the working directory inside the container. And then it will run this command, which is pip install request and beautiful soup. So these are the two dependencies I need for my simple code. And this CMD will be the command that will run when the container is running. So this one will run only once, but whenever the container is running, it's going to be running this. So I want it to run the actual script. So this is just the Docker file. Okay. So after I have this, basically this is what I need when I write my own, like I'm Dockerizing my own application, right? Basically, I can send this Docker file to someone to create a Docker image from it, or I can do that myself. So basically, the next step is going to be to create a Docker image. So to do that, what you have to do, like I'm going to cd into, let me see a second. So where am I? I just need the path to this. Okay. So I'm inside the directory where this Docker file is, right? So I have Docker file here. And what I'm going to do, because I have Docker running already, so sorry, not Docker, I have it installed, not running. So I have, do you see my, like, when I'm running these commands here, right? So I have Docker installed on my machine. So what I need to do is to build an image. So what I need to use is Docker build, and I can call my image something. So let's say I will call it I don't know, some movies. Let's say it's a get movies, but this is my app. Get movies app, and then I will have to tell it where to find the Docker file, which is this working directory. So I will just put dot and run this. And this what it's going to do is going to create this Docker image that I need. So it will take a bit of time. And basically this image, you can deploy it to Docker Hub, or like somewhere for other people to just download this image, and from it they can run a container on their own machines. So after finishing building this image, you're basically done with containerizing your app. But I will show you how to run a container on your own machine as well. Say like you can be this exact image if I want to test to see it's working correctly, or like can be any other image that you can get. Okay, Okay, just let me open also while this is running. Open Docker Hub and show you like you can get Docker image for different things basically. Okay, so you can see here in the log here is how it's running through the commands that are in the Docker file. So this is the from. It built all the layers that are needed, and then it added the admin.python. It runs the install, and then it created basically the image. So to see that I have it now, wait, sorry. So I can run Docker. So I think it's images. Docker images, yes. You can see, yeah, you can see at the top I have Get Movies app. This is like the image I just created 33 seconds ago, and this is its size. And okay, so there are ways to make like your Docker image most optimal. So with the smaller size and stuff. So I think like the way I created this one is not probably the most efficient way. But anyway, I have it now. And basically I can run it. Of course, I can run my own application here, but this can be any image. And I can also like, let's say, I have other ones here. For example, I have this modified Postgres, but I can like show you how to get one instead. So let me just say like what was the command exactly. So you don't see my full screen. Let me stop because I need to show you the Docker Hub and how. So okay, let me share my full screen. Okay, so here you have, like you can see, this is Docker Hub. This is like where you can publish your image and like other people publish also their images, and you can find what you want. But whatever application you want to run inside the container, you might search for a Docker image there. So what I searched for was Postgres, and I got this. So there is this Postgres that will run Postgres inside the container. So instead of like actually installing Postgres in my machine, I'm going to just get this image, and you can see this small one. So, okay. So what I need is to run this. So this is the name of the image, and I can basically download or install the image in my machine by running this locally. Okay. So you can see here. So it will take some time to run. I apologize for that. And then what I will have to do is just to run docker run and the name of the image to create a container to run the application inside it. So let me just check. So because this, like, okay, just let's I shouldn't have done that. While this is running, let me just show you. Okay. So, sorry, I'm confusing you a little bit. Sorry. I hope that I'm not confusing you. So I'm just going to show you what the code does, just to make sure that when I run it in the container, we know what happens. So just run it. So what I'm doing here, I'm just running this main.py I have. So just running it locally. Sorry. So what I need, I don't have the, okay. Sorry, this will take a little bit of time. The, sorry, -m, so I'm creating a virtual environment to install the library. So it will take me time to do this as well. Nothing is going to run quickly. Okay. So just to not take so much time over that, I just wanted to actually run this app. I have, well, it's a standing app for me. I'll run it locally and then run it inside the container and show you that it's working. But because that will take time, I'm just going to show you the command that you need to use, which is like docker run, and just to make sure that like I'm using the right thing. So what I need is the name of the Docker image and whatever like command I want to run after that. So I can also name the container using -- name. Right, it's here somewhere. Anyway, yes, let's turn this. So so just running for like an interactive. Okay, right. So okay, so let's see the name of the Docker image again. So this is my Docker image name. I need to run, right? Is this, and I can run it with a tag name. Basically, I want it to be, so this is the container. So this is the name of the container. I made a mistake. Yeah, so the name of the image has to be at the last thing. So yeah. Otherwise, I'm making a stupid mistake, but I don't know. Sorry. Forgive me just 1 second. I forgot the syntax of the okay, so it's docker run. And just to make sure that I have thing, it's not -t. Yeah, it's not -t, so it should be name. Yes, it's name. Yeah. Okay. Right. I wanted to call it something, but all right. So again, I apologize, but so it's run. -i-t is going to be the command that is going to be running inside the container. And so I just want to, like, basically what I'm doing here is just I'm going to get the terminal inside the container. And then what I have is in can name So this is the name of my Docker image, and I want to name the container something, but okay. I can use it to name the container a particular name, but if I don't include a name, it's going to just give it some kind of random name. We'll find it out after. Okay. Um, something is missing. I'm not sure. Okay. Just let's try, because we also have let's try another. So I have Postgres. Can do this with Postgres instead. Because the Docker image I created has some problem. I have to correct that later. But anyway, just to show that we can do this. Okay, it requires some kind of password. All right, so this so wasting a lot of time here. Yeah, finally. So for Postgres, it requires me to run also to set the, going to set the user and the password for that. So it's going to take some time to run, but okay, so let's continue just and come back to it later. Basically, sorry if about the errors, but so if just to recap, what we did in the first step, when we wrote the Docker file, we created the image. And then when we ran Docker build, we created, sorry, this is a Docker file. We wrote the Docker file. This is a blueprint. Then when we ran Docker build, we created a Docker image. And you can run the image to create a container where the app is going to be running. Basically, this is the app running. So once this finishes, it will be my Postgres is going to be running. Okay, so I just basically I opened the app. This is what I did. I hope that's clear. And yeah, so I just want to go back to the definitions. Yes. Yeah, so basically, yeah, and on Docker Hub you can find like images for Docker images for whatever, and you can also publish your own for your own application. Okay, so let's say that's it for this. Any questions? No questions for now. So there are more things. Just I'm going to mention that there are like you can basically create. Okay, Hassan, go ahead. Yeah. Is that a question? Okay, go ahead. So, okay, I will stop with containerization at this step while, how to say, there is more, like like once you get to use it, there are more things that you can do. And basically, when you run multiple container app, basically, you can create multiple Docker files and connect all of them in a Docker Compose. It's a Docker Compose.yaml file, and you can run them, but it's the basic things. Docker Compose is going to be just like for multiple Docker files, which is like a multi-container app. And you also create an image from it and you can publish it. And again, you can run it the same way with using Docker run. So that's it. Let's move on to CICD. So CICD is short for continuous integration or continuous delivery or continuous deployment. Let me just check because I have problems. So do you hear me? Can I get some reactions that you hear me correct? Do you hear me clearly? Thank you. So yeah.
Okay.
Okay.
Okay. Can I continue my question?
Yeah, we can continue. Sorry.
There is some muting problem, so I'm solving it here. So I have one or two questions.
Go ahead.
On Docker file,
Yes.
what is the main objective to need to develop a Docker file? Is only for image or have another function?
It's only for what? I didn't hear you.
It's only for image or have other function?
Yeah, it's a pity that I don't have this running correctly. So basically, let me say. So here, like I have this application. Okay, so my application here is just one file. It's not this complicated, but like in what you are working on, you have multiple, you will be having multiple files, you have scripts, like maybe multiple modules, and then you have like a main file that is running that you can run basically depending on all of these dependencies. I also like my app here depends only on two libraries, Request and Beautiful Soup. But you can also have like a long list of the dependencies. You can have a requirements to text file, right, that have all the libraries you need. For example, this is like, I'm thinking about Python. So, okay, anyway, I created this code and it runs on my machine. Well, no problems. But say I want you to run this, my app, I want you to run it on your machine. Of course, I can send you this code. Like I can bundle, like I can just create a zip file with all my code and give it to you. Just send it to you and you run it on your machine. But because you don't have the same dependencies I have, my machine, I'm running a particular OS. I'm running like Linux, or I'm running Ubuntu 24.04. And for example, and you are running something different. Let's say you have Windows. You're not going to be able to run it the same. You have to install dependencies, the dependencies by hand, right? So it will take some time for you to actually run it, and probably maybe you're not going to get the same result I'm getting at all, because some of the dependencies are not the same. To avoid this problem, you create basically a container. And to create a container, you have to create 3 steps. You have to create a Docker file, and then a Docker image from this file. And I can basically send you, basically the Docker file itself, or I can upload the Docker image and basically can use that image directly from Docker Hub, and you can run a container. So the container, it will have the dependencies inside of it. They are bundled together. You don't need to install anything. You just enter the command Docker run this particular Docker image, and it will run. The application will be running inside the container. So what is the use of it? It's a deployment method, or it's a like I'm bundling. It's the portability of it, because I just sent you the Docker image and you used it right away. It avoids the problem of environments. Yeah, different environments are not a problem. So does that make sense to you? Does that answer the question? What is the main use of this?
Okay.
It's not
Thank
super
you.
clear. Is this not super clear?
So after we implement or after we
Mhm,
write a script or a doc file and then
mhm.
we define the image, where we get the image is online or on local machine.
Basically, yeah. So you can publish the Docker image online in Docker Hub, basically. You can have a different deployment, like you can have a different server you want to put it in. So it's not like if you want. Basically, you can have just the image in the Docker image itself, like say in your code with your code. You have your code on GitHub, right? So with
Yes.
your right with I want to open some example. Second, yes, I had something open earlier. Make sure. Um, okay, correct. So yeah, like say you have this code, or it's just code. It's got some like this is from some tutorial actually. It's linked actually in the slides. So you have the different parts of the code. You have the source and here in your repository, and you add the Docker file with them. So this Docker file is based on yeah. So this Albine, and then it's running this particular. This is the entry point for it. So this is a Java application actually. Anyway, you can actually just have the Docker file with your repository. You don't need to actually publish the Docker image for now, maybe. This is enough because like if I have this Docker file, I can create the image myself the same way I did just before and run the container with it. But you can also create the image and publish it to 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 Docker Hub here. Like there are like so many Docker images here. All of these are different Docker images for different things, and you can basically publish yours also there. Yeah. Is that the last answer question?
Yes.
Okay, great. Yeah, so let's continue because we are running out of time. I'm sorry about that. So just to say, this is blah blah blah. The CICD, continuous integration, continuous delivery. It's the idea is to have like the aim of this is to streamline and accelerate software development lifecycle. So this is an automation pipeline. So you have a CI/CD pipeline, it's an automation pipeline. It's one of the important components of DevOps, the DevOps framework. So the continuous integration is the first part, like when you build and test and merge. So basically, think when you are using GitHub repository to you're using Git to for version control. Basically, whenever you make a change in the code, you can make a commit, right? But if you're working, say you want to work on a team, right now you're working separately, right? Individually on your code, but usually you're working on a team. You can be working each developer is working on a different branch or a different part of the application, and basically, like you can be working a different branch on the repository, but then you want to merge all the codes and new code together, right? So because like of course you can do this manually. Like I worked on some part of the code, you were like someone else worked on some other part of the code on different branches. there might be some kind of conflict because like we changed the same piece of code at the same time. There might not be, but to make sure that we don't get any problems, we have to check. We have to check that we don't like if there is a conflict or not, but also we have to check that whatever changes we are doing, we did don't ruin the application that maybe is already being used or already working. So for that, we have the like building, testing, and merge. These are, you can create tests. Okay, so again, so this what I was described, it can be done manually. Someone can go over the code, the new changes, and check and make sure that like everything still works, like there are no conflicts and stuff, and merge them, of course. But this is going to be tedious and life time consuming, and people make mistakes, of course. So if you can automate this part, this is what is called continuous integration. Automating it will make it like easier, like uh, ensures the quality of the code, and what also like make it faster to do. So this is the first part of it, continuous integration. So the practice automatically and frequently integrating code changes to a shared source code repository. So think of GitHub repository, making changes to a different branch, and then when you're merging it with a pull request, this is where the continuous integration can happen. You can write test, what is called, like we have unit tests, you come across this, and there are also integration tests. You can write those and automate the testing on each pull request using, for example, GitHub Actions, right? So this is what is called continuous integration. So so as I said, like this makes the changes to applications are merged. Like we can write tests, and then they are going to be run automatically to and ensures the quality of the code when it's changed. The second part, which is the continuous delivery and continuous deployment, this is okay, so this is these are further steps in the pipeline. So CD can be continuous delivery or continuous deployment. And so the continuous delivery is the least amount, so the least amount of automation here in between the two. And it automates the release of the validated code to a repository ready for production, ready to be released to production, basically. So it's ready to be released, but is not released in the continuous delivery. The continuous deployment is the one that automates also the release. Think about an application or software that is used by users already, and basically you can automate each step until like it reaches the users. But a lot of companies or a lot of teams prefer to use continuous delivery instead of continuous deployment, so that this last step to deploy to the users is like still manual. There is still manual gatekeeping at this point, manual testing or manual approval of this step. So yeah, so CD can mean either of these versions. And because like we can say a lot of stuff, but because I'm running out of time, what I'm saying is here is what you I wanted to emphasize is using GitHub Actions for as a CI/CD platform. So GitHub Action, and maybe you already use this or not. Let me open my just so like this is my own GitHub, and let's see this to see it. So okay, So basically this is the same. What I'm going to show you here is that like you can go to actions here and you can see the different workflows that you can run with GitHub Action. So GitHub Action can do a lot of things for you, but basically what maybe you have already seen is that you can use it for testing, as I was saying, to run automatically, to run testing automatically at pull requests. So this is a form of using, this is a part of a CICD pipeline. Because like there is not enough time, okay, so what we'll have here once you use it, like I was showing here, like okay, maybe with this example here. So you can find like you have .github workflows here, and you like the workflows are defined in .yaml files, and basically, okay, you can check maybe the website to see like what is the components of these .yaml files. So there are like how to write them. So what is like the event at which the like the workflow is triggered. The job is what is going, the steps of that are going, the commands are going to be run, or whatever action is going to be happening. So in this case, so the events here are on push and pull requests, and the jobs here like to run on the Ubuntu. So basically here everything is going to be running on a server like on GitHub, and it's using Ubuntu for this case. And these are the different actions that are going to be run for at every pull request or push. And so yes, described with name and exactly how to run them. So in case of a test, this is going to be running the tests we have, unit test and integration test. You can also run to basically build and push a Docker image, as you can see here. So here what you have is the name and also these are user and password for the Docker Hub. Here you have to define them. So basically here what we are testing is that like whatever change in the code you made, you're going to update the image you have already uploaded on Docker Hub with this new change. And you are testing that like you're not breaking, like still can still run and can still, let's say, this is one thing you can do, but can also actually run unit tests and integration tests other than that. So yeah, so I didn't like, there are a lot of things that can be said as well, but I'll stop here. So any questions? I hope that I just gave you some like idea of what you need to do this week, basically to implement that, basically create a Docker file for your application and use you have to like get used to it, look into it more, how to use GitHub Actions if you haven't done that before. There are other, it was difficult to cover this because I don't know if I have come across how to write unit tests, how to write integration tests, and how to run them as well. But I just have you right now, you have the theoretical understanding, or basic theoretical understanding, I hope. Okay, any questions? So there is a question in the chat box. I didn't see it before. Asmare, I think. So what is the importance of Docker over Python version environment? These are two different things. So in a version environment is like, well, there are something. Yeah, I get there are some similarity between the two things, because when you create a virtual environment to your machine, what you're doing is that like the dependencies that you install in this virtual environment are not going to be affecting the other virtual environment that you create, right? So on the same machine, you are still installing the dependencies in your machine. They still exist on your machine. You can find them, but they are kind of isolated, so they don't affect other virtual environment. But this is for Python dependencies alone, right? And the application can be used in many different things, not only Python, other stuff that cannot be how to say, they cannot be isolated. Another thing that these dependencies that you install in a virtual environment depend on your OS. They are not independent of that. So it's still you have other dependencies of on your operating system. The container is completely isolated. It's like you can use basically in the Docker file or in the Docker file, you can have Ubuntu while you're running on Windows, or you can have Windows while you're running on what's actually not true. But anyway, you can have any kind of dependencies. So it's just even more generally applicable, not just for Python, and everything is not on your machine. Once you stop running the container, these dependencies don't exist on your machine anymore. So yeah, I hope that's clear and answer your question. So there are similarities, but yeah, it's just more generally applicable and more isolated and more independent of your OS, the container. Okay, another questions? Um, all right. Okay, so because we are over time, we can stop here. If you have any questions, further questions, anything that is not clear, you can just ask on Slack. You can tag me there. And yeah, thank you everyone for being here, and have a nice rest of your day.